Hello everyone, this is our project Flying Marco Polo. We are Gongqian Li, Jing Zhou, and Chong Wang. I believe some of you may have the dream of traveling around the world. 800 years ago, Marco Polo traveled across the Eurasia continent without enough information to plan his trip and without the efficient transportation system. But it is 21st century now, we have airplanes and we have internet to access to all kinds of data. Here, we have built a travel planner to help those who want to be a modern Marco Polo who travels around the world with shortest total distance. The problem can be abstracted and described in a graph, considering an undirected and weighted graph, such that the city is the node of the graph and the reachability and flying mileage between two cities is the edge and its weight. We want to find a path with minimum weights that do not visit the node twice. You may think, our problem is a traveling salesman problem, which is based on complete graph and Hamiltonian path. Yes, you are right, but they have some differences. Firstly, the connection between cities are restricted by the flight history data. There may not be a direct air route from city A to city B. Secondly, we allow repetitive visits for every city in order to get the shortest total traveling distance, which means our result is no longer a Hamiltonian path. We get our flight data from OpenFlight and air carrier statistics. We use over 5,000 airports, around 100,000 international and domestic flights, and around 1.2 gigs flight data. We store our datasets in MySQL and then use Spark to query the information. We implement several algorithms by Python to get the ideal path for the trip. Finally, we show our results through website by using Flask and Google Maps. The server is built on AWS and the website can be accessed publicly.
And so, here is our outcome. We built an interactive website called FlyingMarcoPolo.info. Let's check it out. This is the optimized route for traveling around most capital cities around the world. In total, it takes around 200,000 kilometers. And we found some interesting spots, like French Guiana. Here it is. Since the route is generated by real flight data, French Guiana can only connect to Paris. So our Marco Polo has to cross the Atlantic Ocean to visit this city. In our second mode, we take airline company attribute into consideration. We choose American Airline and its flight to generate the shortest route. As we can see, some cities like Charlotte, Philadelphia, and Chicago. This city act as hub city in United States. This function could help those who want to choose an airline company credit card. And holiday mode is a more practical and more interesting solution. In order to travel around the world, our Marco Polo, a very busy man, can only go abroad in his Christmas holiday week. That means, in the end of the holiday week, Marco Polo has to come back New York. For example, this holiday week, Marco Polo decides to travel several cities in Central America: Mexico City, San Jose. If he spends all his holiday week traveling, it will take around 50 years to travel around the world. Also, we provide the real-time interaction. This application generated optimized route based on your input list. The cities are separated by comma. It will take a little while because we automatically run a new query to acquire data from our database and run simulated annealing algorithm. Here is our outcome. And let's try another example. Some city in Europe. Here it is. If you want to try your own city list, please contact us and we will start the server for you.
Then let's take a close look at our algorithm. Because our route design, like TSP, belongs to class of NP-hard, we choose 3 typical approximation algorithms to calculate the routes on 150 cities. Greedy algorithm is easy to implement with given seeds. In average, it gives a distance of around 100,000 kilometers, and the results are poorly organized. In terms of the genetic algorithm, the distance is improved from 800,000 kilometers down to 241,000 kilometers by increasing the number of generations. Simulated annealing is our most effective and efficient algorithm. The setting of appropriate initial and terminated temperature can decrease the mileage to 200,000 kilometers in 10 minutes running time. Annealing algorithm can avoid falling into local optimality and is somewhat efficient in our real-time computation scenario. In our development, we find it is still a challenge to do efficient queries even with Spark. Moreover, we cannot do the real-time calculation on real big data, for example, hundreds of cities. It involves the trade-offs between the optimality and the running time. In the future, we can improve our planner by considering other means of transportation and find solutions to give the traveling schedule with estimate time consumption. That's all. Thank you.